Hey everyone, this is Miss Moriarty, and I'm here to discuss with us the remaining parts of topic 5.15, which was all about sustainable agricultural practices, and a little bit about topic 5.5, which is on irrigation. So we left off in talking about sustainable agricultural practices such as things like contour plowing, strip cropping, crop rotation, and so on. Now, the reason why we tend to do practices such as those is to try to maintain the soil's fertility. Right, we learned that in our city interactive, right? Each and every time you tried to plant the same exact crop in the same spot, right, it didn't really let you do that, right? It always wanted you to rotate your crops because if we continuously plant the same crops over and over again, we're going to deplete the soil of those specific types of nutrients. So, how can we not only increase the soil fertility by practicing things like crop rotation? What else can we do to increase its fertility? We can add things like green manure as well as limestone as well. And I'll get into those in just a second. But specifically looking at crop rotation, we know it's the practice of growing a series of different types of crops in the same area, usually in a sequence typed season. Um, we usually tend to see this because it can help soil erosion and increase any soil fertility or crop yield. What about green manure and what it is? Well, in agriculture, green manure is created by leaving any uprooted or sown crop parts left over from the harvest. They tend to then wither on the field and they kind of serve as like a natural mulch or soil amendment to the field. The plants used for green manure are often things like cover crops or perennial plants that aren't actually the target crop that you are harvesting for agricultural purposes. We also said that limestone has the ability to help increase soil fertility. The reason why is because it's going to reduce any toxic levels of soluble aluminum and manganese. Limestone can also help adjust any of the pH found in the soil. So if you have very acidic soil, right, very low pH, it's going to be a lot harder for those roots to actually capture any minerals or nutrients. Same thing if the soil is far too high, right, in terms of its pH, if it's too alkaline. If it tends to be just right, the plant uptake availability and its ability to take up any nutrients like potassium, phosphorus, and so on is much better. So, limestone is a way in which we can try and make sure that the pH is just right. Now, the other piece to sustainable agricultural practices involving specifically livestock would be rotational grazing. We saw this in our Fresh documentary, right? The farmer Joel Salatin, right? We saw that he implemented a natural migration pattern to a lot of the cattle he was raising. So he would rotate where they would then feed upon the grass each and every day. And then he would follow that up with any chickens to then break up any of the cow manure, eat any of the pests or insects that were a result of the cows being there. Okay. Now, moving on from sustainable agricultural practices, another piece of Unit 5 is specifically talking about how we use water. So far, we've mentioned, right, how we might use the resource of soil, how that's going to provide us crops, how we raise our crops, how we raise our livestock, and the resources that go into then raising those pieces. But now we're going to kind of solely focus on, well, how do humans use water and in what ways? So there's three categories that we can split up global human water use, and that is agricultural purposes. So that would be using water for livestock and just irrigation water for crops. Municipal, which is simply the water that you use in your house. So things that you use for like toilet, shower, drinking water. We can also see an industrial use of water. Lots of power plants tend to use water as a cooling factor. Same thing with any big metal or plastic manufacturing companies tend to use water for that same purpose. But you'll notice, though, in the pie chart to the right, majority of our human water use tends to gravitate more towards agriculture. So it's key to understand, well, how do we use water for agricultural purposes? So that brings me to topic 5.5. So that is irrigation methods. Now, back in 5.3, when we talked about the Green Revolution, right, the change from having not as many crops being grown to then increasing our crop yield. And a part of that increase in crop yield was the implementation of machinery, synthetic fertilizers, and a piece of that was actually better irrigation methods, right? Better ways in which we can water our crops. Now, the largest human use of fresh water tends to be for irrigation purposes. Now, the types of irrigation we need to know for this course are things like flood irrigation, furrow, drip, and spray. You will need to understand the efficiency of each, the evaporative water loss of each, and how cost effective it may be. Now, specifically looking at flood irrigation, kind of sounds exactly as what it does. You literally flood the entire field with water. What are some pros? What are some cons? Well, some cons, you can actually create a waterlogging situation where you have simply just too much water is left to just sit in the soil. This can raise the water table or the amount of water that's found underground, and it can inhibit the plant's ability to absorb oxygen through their roots. Another con, this is the method of irrigation where we're going to see the most loss to evaporation and runoff because we're simply just flooding the field with water. We're not really targeting each crop with that said water. Now, what might be some solutions to this? Maybe implementing a drip irrigation type style, maybe aerating the soil, right? Poking holes or cores in the soil to allow that air mixture and the water to drain through the soil. Now, if this has so many cons, why do farmers even still do this? Well, it's really easy to do. You're simply just flooding the field with water one time. There's really no machinery or much money involved in this process. The next piece is furrow irrigation. So as you can see in the picture here, this is actually where you dig small little trenches in between your target crop rows and you make furrows. You fill those then with water. Kind of similar to our flood irrigation. It's a pretty inexpensive process, doesn't really involve very many machinery. It doesn't quite lose as much water to evaporation as flood, but we can still see about a third of the water is lost. Now, the next piece is spray irrigation. This one you might most often see in farms. This typically involves machinery in where water is actually pumped from groundwater into spray nozzles. This is way more efficient than, say, our flood or our furrow irrigation. Only about a quarter or less of water tends to get lost in spray irrigation. However, because it requires machinery and fuel to power that machinery, it is more expensive than both our flood or furrow irrigation. The last type of irrigation is drip irrigation. This is where perforated hoses are then lined up along the target crop. They release very small amounts of water directly to the plant roots, making this the most efficient type of process because we see the least amount of loss of water to evaporation in this type of irrigation. However, to implement a drip irrigation type system, it can be quite expensive, so it's really not used as often as, say, spray, furrow, or even flood irrigation. All right, everyone, this is the end of this video at this point. Please make sure you mark this video as done and complete the drag and drop posted to Classroom.